Alright, hi there, this is Christy's eye video for eye anatomy and functions of the eye. So we're going to start with the optic nerve. First of all, I apologize. I'm really stuffed up. My students got me sick, so I apologize. I hope you can still understand me. My pronunciation might be a little off right now. We're going to start with the optic nerve, which, according to my picture, is in the posterior segment of the eye. It's actually in the far back of the eye. And that's going to be the bundle of fibers that carry the vision from the retina. The retina is going to get the impulses, the light, going to turn it into electrical impulses, and the optic nerve is going to take that to the brain to become what is sight, or create the pictures that we know to be as sight. The next section is the optic disc, and the optic disc is ultimately a blind spot for us. It doesn't have any cones or rods, which we need in order to see, so it is the blind spot of the eye. The next section is the fovea centralis. And that is located in the macula, again in the posterior segment of the eye. It's actually, the fovea centralis is part of the macula. The macula is a thinned out portion of the retina. And the fovea centralis particularly has the highest concentration of cones in the eye. Cones are the photoreceptor of the eye that are able to see or sense light. Rods do not. They are more light sensitive, but they do not perceive color. So fovea centralis also has the highest, the macula and the fovea centralis have the highest level of visual acuity. This is the only place in the eye where 20/20 vision is possible. Moving on to the choroid. The choroid is the layer between the retina and the sclera, consisting primarily of blood vessels which provide nutrition to the retina. So the choroid is very vascular. It's bringing blood to the eye, and essentially feeding the eye. The sclera is the tough outer white part of the eye. That's the part that I always irritate whenever I'm trying to put in contacts or, God forbid, take them out. Scleras are pretty tough. When I was in high school trying to dissect a cow's eye, it was actually fairly difficult to make a hole in. High school anatomy classroom scissors were not the greatest tool. Definitely could have been a little bit better. But things you remember from high school anatomy class. Anyways, so from the sclera, we are moving on to the suspensory ligament. And that's the long, thin fibers which connect the crystalline lens, so the lens of the eye, to the rings of the ciliary muscles. So the suspensory ligaments are really what it's going to help hold the lens to the ciliary body, so that the ciliary body can accommodate the lens or adjust the lens to be thinner or thicker. So from the ciliary body, from the suspensory ligaments, we're actually going to move on to the ciliary body. Ciliary body does two main things. The first, like I mentioned, it accommodates the lens, so it helps make the lens thinner or makes the lens thicker. And it also produces the aqueous humor, which is something I'll be explaining in a few minutes, or a minute or so. So the ciliary body has two main purposes: lens accommodation and producing that aqueous humor. We're going to move on to the lens, and the lens is the the resilient transparent structure in the eye that focuses light by changing its curvature. So again, that accommodation of thinning or thickening. It provides secondary refraction. So the lens does not provide the main refraction of the eye. That's actually the cornea, which I'll get to. And the lens is located behind the iris. So when you're looking at somebody dead on, you're going to see the iris, the color part of their eye, and the lens is located behind that. Alright, so from the lens, we're going to move on to the aqueous humor. That's what I was talking about earlier. The aqueous humor is located in the anterior part of the eye. That's the front part of the eye. and it is produced by the ciliary body. So the aqueous humor is going to provide a lot of the nutrition needed for the front part of that eye. It's really nourishing the front part of the anterior part of the lens, the anterior part of the eye, and the lens as well. The next part is going to be the cornea. So the cornea is what actually provides the major part of light refraction for the eye. And it's the front transparent part of the outer protective layer of the eye. And again provides that major refraction. So this is where you're going to have issues like astigmatism, nearsighted, farsightedness. These are all impacted by the cornea and the shape of the cornea. The pupil is the round hole in the center. If you're looking, it's going to be in the center of somebody's iris. And it looks like it's black, but it's actually a hole that leads to a chamber that doesn't reflect any light. So that's why it appears black. The next section of the eye is going to be the iris, and that is the colored part of the eye. Again, that's what you're going to be really seeing when you're looking at somebody. When somebody says, "What color are your eyes?" they're referring to the iris. And the iris contains the pupil, and it also controls how much light is being let into the eye. So a good example is when you turn the lights off, your irises open up the pupil to let more light in, and when you turn the lights on, they're going to constrict the pupil so that you aren't letting as much light in because you don't need that much light when the lights are on. So the reason why it hurts when you turn the lights on when it's been dark is because your eye is all of a sudden getting more light than it needed to see, and your pupils hadn't adjusted yet. So we're going to move on to the canal of Schlemm. Up here, again, still in the anterior portion of the eye. Canal of Schlemm is basically a drain. It drains the aqueous humor from the anterior portion of the eye into the venous system, which is to the blood, essentially. Moving on to the conjunctiva. Oh, my pronunciation sucks. I'm so sorry. And the conjunctiva is the thin membrane, clear membrane, that covers the front of the sclera and lines the inner portion of the eyelid. This is what gets irritated with pink eye, and if you're scratching and such, this is the part of the eye that can get really irritated and itchy and sore. The ora serrata is really the junction of where the eye goes from non-photoreceptive to multi-layered complex photoreceptiveness. So really going from more of a simple area of the ciliary body to the more complex area of the retina. And then moving on from the ora serrata to the vitreous humor. Vitreous humor is like a jelly that provides nutrition to most of the eyeball. It's in the posterior segment, or the back of the eye, behind the lens in the ciliary body. In high school anatomy class, I pulled that out of the eye and held it, and it really is like jelly. It's kind of interesting. And then last but not least, we have the retina. And the retina is very much not the least. And that's the inner lining of the back chamber of the eye, the posterior part of the eye, that contains layers of nerve cells that receive light rays and convert that light into electrical impulses. So basically, the light that's refracted by the cornea and the lens hit the retina turns it into electrical impulses and sends it to the optic nerve. Fun fact, in that high school anatomy class, when I was dissecting a cow's eye, it always struck me at how pretty the retina was. It's black and then looks like an oil spill of colors across it. And 10 years later, that's still kind of an image that has stuck with me, is just kind of what a weird place to find beauty in a cow's eyeball. So thank you so much for watching. I hope I covered just about everything. Again, I apologize for my stuffiness.